So now we are going to see the mediation device protocol. The mediation device protocol is compatible with the peer-to-peer communication mode of the IEEE 802.15.4. It allows each node in a WSN to go into a sleep mode periodically and to wake up only for short times to receive packets from neighbor nodes. There is no global time reference. Each node has its own sleeping schedule and does not take care of the neighbor's sleep schedules. Upon each periodic wake up, a node transmits a short query beacon indicating the node address and its willingness to accept packets from the nodes. The node stays awake for some short time following the query beacon to open up a window for incoming packets. If no packet is received during this window, the node goes back into sleep mode. When a node wants to transmit a packet to a neighbor, it has to synchronize with it. One option would be to have the sender actively waiting for query beacon, but this wastes considerable energy for synchronization purpose only. The dynamic synchronization approach achieves the synchronization without requiring the transmitter to be awake permanently to detect the destination's query beacon. To achieve this, the mediation device is used. The mediation device is not energy constrained and can be active all the time. The scenario is illustrated in this figure. Because of its full duty cycle, the mediation device can receive the query beacons from all nodes in its vicinity and learn their wake-up periods. Suppose that node B wants to transmit a packet to node C. Node B announces this to the mediation device by sending periodically requests to send packets, which the MD captures. Node B sends its RTS packets instead of its query beacons, and thus they have the same period. Again, there is a short answer window after the RTS packets, where B listens for answers. After the MD has received A's RTS packet, it waits for B's next query beacon. The MD answers this with a query response packet indicating B's address and timing offset, which lets C know when to send the answering clear to send to A such that CTS packet hits the short answer window after B's next RTS packet. Therefore, C has learned B's period. After B has received the CTS packet, it can send its data packet and wait for C's immediate acknowledgement. After the transaction has finished, B restores its periodic wake-up cycle and starts to emit query beacons again. Node C also restores its own periodic cycle and thus decouples from A's period. Advantages: it does not require any time synchronization between the nodes. Only the mediation device has to learn the periods of the nodes. The protocol is asymmetric in the sense that most of the energy burden is shifted to the mediation device, which is so far assumed to be power unconstrained. The other nodes can be in the sleep state most of the time and have to spend energy only for the periodic beacons. Even when the transmitter wants to synchronize with the receiver, it does not have to wait actively for the query beacon, but can go back to sleep and wait for the mediation devices to do the synchronization network. The way very low duty cycles can be supported. Drawbacks: the nodes transmit their query beacons without checking for ongoing transmissions, and thus the beacons of different nodes may collide repeatedly when nodes have the same period and their wake-up periods overlap. The wake-up periods are properly randomized and the node density is sufficiently low. The collisions probability can be low too. However, in case of higher node densities or unwanted synchronization between the nodes, the number of collisions can be significant. A possible situation is to this is the following. When the MD registers collisions, it might start to emit a dedicated reschedule control frame. All the colliding nodes can hear this frame as long as the MD repeats it often enough. Reception of this frame causes each node to randomly pick a new period from a certain interval A, B indicated in the rescheduled frame. The MD continues to perceive collisions. It can enlarge the interval accordingly. The mediation device is energy constrained, need sufficient mediation devices to cover all nodes. Coming to drawbacks, the nodes transmit their query beacons without checking for ongoing transmissions, and thus the beacons of different nodes may collide repeatedly. When nodes have the same period and their wake-up periods overlap, if the wake-up periods are properly randomized and the node density is sufficiently low, this collision probability can be low too. However, in case of higher node densities or unbounded synchronization between the nodes, number of collisions can be significant. A possible solution to this is the following. When the MD registers collision, it might start to emit a dedicated reschedule control frame. All colliding nodes can hear this frame as long as the MD repeats it often enough. Reception of the frame causes each node to randomly pick a new period from a certain interval indicated in the reschedule frame. The MD continues to perceive collision. It can enlarge the interval accordingly. The mediation device is energy constrained, needs sufficient mediation devices to cover all nodes. Thank you.